We're going to spend a little bit of time today, tackling the subject of private cloud. Kind of talk a little bit of an overview of what private cloud is, really. Maybe hopefully dispel some myths about it, and then go through some use cases and look at the private cloud from kind of the RightScale perspective, from the RightScale management platform, the actual user interface and things. And I'll assume that all of you guys got the prerequisite for the course, which was you guys have all stood up your own private clouds and have it operational, correct? Everybody's done that here? Yeah, no, you don't have to leave, so it should be okay. But so what I'm going to do is, that's going to be the basis really of what I'm going to talk about. Is so this idea of going from this concept of what, everybody's heard about private cloud, but nobody's really seen them yet. Really, what does it look like? What are some of the components? So I always find it's useful here to talk about these concepts so that we have a common frame of reference. So hopefully you'll find that useful. We'll talk about the different components that are built in here at a very high level. We won't necessarily talk about any specific cloud technology, but we'll talk about just them in a general sense. And then, some of the middle items here we're going to go through are just some of the dynamic configuration tools and some of the methodology that we use to approach these private clouds to dynamically configure them and give them some extra functionality. So that's really the tool set that's involved there. And then, as part of the demo section, I'm going to go ahead and kind of walk you through just some of the basics of connecting up. Looking at the RightScale dashboard, how do you connect that up? What are some steps? Where do you begin in this whole process? And then I also have a hybrid cloud setup inside of my account that I'll be showing off. So it's kind of a cool little demo. We've got a public Amazon load balancer sending web traffic to not only a Eucalyptus private cloud that's residing inside of RightScale's property. So we set up our own Eucalyptus cloud there with a few different nodes. But then we're also sending out that traffic to a cloud.com cloud that's in their possession. So they actually set up a cloud that we're using for a demo. So we have a public cloud and two private clouds, but in two physical different locations. So it's an interesting use case, and we're able to send traffic between those two. So, and cloud.com is even going to be here a little bit later today showing kind of a more advanced example of this, which will involve scaling, sending traffic using load balancers to send traffic into your private data center using cloud.com, and then bursting out to handle excess capacity in the Amazon public cloud. So we're going to see two cool examples in this track here. So this thing, do private clouds really exist? And for the discussion that we're going to talk about here today, yes. There's not really any good examples of private clouds that people can point their finger at and say, this is working. There's no good referenceable architecture out there. People are really trying, but it seems like right now the level that's being built is really the proof of concept. The simple nodes, just kind of either almost like a mom and pop shop, a small research team, something like that. There's not really this big shining private cloud example out there. But what's really cool in the last probably year and a half, I personally, while working at RightScale, have seen this idea of private cloud go from this buzzword, general concept to actual, what I call vendorware now. So it's moving beyond this phase of, oh, it can be done, or we will have a product, that we are starting to see real cloud-enabling technologies out there. And a couple of them, that we support right now out of the box are cloud.com and Eucalyptus. And then we're adding support rapidly for, any kind of viable third-party clouds, private cloud software that will become available. Yeah?
Did you leave Open Nebula for a reason?
Or? What was that?
Open Nebula?
No, I didn't. This is not a complete list. Okay. So really what we have, so he asked if we left Open Nebula out, which is kind of a research, well, I guess not necessarily a research project, but it started as a research project. It's kind of an open source, similar to maybe OpenStack or something like that. So it's a very interconnected, open system for connecting your clouds. But no, the answer is, these are just kind of what came to mind. So the first two are ones that we actually support now. The rest, we are adding support. And then we're going to add continued support as other viable, software packages come out there.
If I had to play with RightScale and Open Nebula, I can do that today?
Probably not at this moment, but soon. Yeah. Good question, though. And then, there's also a comparison, from this vendorware or vaporware to vendorware. There's a few different flavors out there, and the two major categories really, and all of these guys are doing this so far. Like the Eucalyptus and the Cloud.com, there's usually an open source track, and then there's a commercial enterprise track. So, they kind of hook you in with the open source to test out the software and kick the tires on it. But then, the commercial offerings seem to have a lot of the extra feature sets that people are looking for. But there are, even though there are enterprises that are deploying real private clouds today, we just don't necessarily know about them yet, but people are starting to experiment in that area. So when customers come and talk to me or RightScale about things, they're usually in one of three phases of this kind of private cloud project, and maybe you guys can recognize this or see yourself in these examples, because either they come to us and they've had experience in the public cloud, they've had some kind of a success. Maybe they've been running a Facebook game in the public cloud, and they like the way that it performs. They like the flexibility and the adaptability and the price and performance of it. And they want to take that application or those kind of results and move it into a private cloud. So what they're doing is, they already have the tool set. They know about the public cloud. They just want to adapt that and layer that onto their own internal infrastructure. So they want to get a lot of the same benefits of the public space, but maybe a little bit more control over costs, over performance, over just the infrastructure itself. So that's kind of those are pretty much the early adopters of the private cloud space. So they're really leading the forefront, and these are probably in my experience, some of the larger enterprise type customers, some of the advanced gaming companies and things. What we also see are customers in the proof of concept phase. So these are the ones who want to start some kind of project. Maybe they haven't even identified what it's going to be, but they want to get a small team inside their company trained and experienced on private clouds. And one way to do that is really to get an open source package, start installing it locally, getting some teams trained on it, kicking the tires, finding out where some problems might be, maybe what some limitations are, and even if it's a feasible concept to move forward with. And then the third group here is just the information gathering. There's a lot of talk out there about private clouds, but there's not really a lot of concrete information. So everybody seems to be looking for best practices and referenceable architectures and whatnot. And that's one of the main reasons or main avenues that people come to us, then looking for information on.
Can I ask another question?
Yeah.
So if you go back to the
Well, so much for my animation.
So you mentioned that people move from the public cloud to the private cloud. The reason for that is starting to notice that they pay more to the Amazon and Facebook, and they justify their cost savings as doing a private installation. Is that the main motivation to come back to private cloud?
That's probably one of the main motivations. The question is, why are these customers, these large publicly enterprises that are using the public cloud and having success, why are they shifting, to the private cloud? What do they want to get out of it? And I think number one is that, a lot of these larger companies, they do already have infrastructure that they want to virtualize or turn into a private cloud. So, that's an immediate reason, So gaining leverage over the infrastructure, gaining control over the costs, So, Amazon you can rack up a few good charges on there if you're not careful, if you're running these large deployments and things. And then maybe just also a little bit more transparency, a little bit more control over just the whole process. So, I'm sure it varies, from company to company, but that's kind of the primary one. But then they also like the tool set that they've come to enjoy that business model, that workflow as far as deploying applications out in the public or private public cloud space. So let's see here. So this is supposed to be a great animation. So let's back it up here. So basic private cloud. If you guys haven't installed one, I highly recommend, you can go out there and get open source software, download it, load it on a few different machines. It's a little more complicated than you might expect. There are some tricks and techniques as far as doing this, but when you do it, what you're going to find, there's kind of three main areas. And you can think of this in relation to like an EC2, an Amazon public cloud space. So, whereas Amazon hides all the infrastructure and all the details as far as how things are running and what area, what nodes are handling what. If you're going to build your own private cloud, you're going to have to take care of that yourself. So you're going to have to become familiar with this. So what we've got is we've got management nodes. This is kind of the endpoint that RightScale or that your software or your users will talk to. It's kind of the resource controller or the brains of the operation. So it's going to be the one that knows about what kind of resources are available, what kind of virtualized machines are living on your network, what kind of storage system that you might have. And this is also what you would interact with if you wanted to, say, launch your application in your own private cloud. This would be the one that's coordinating it and the security and pretty much all the low-level details of what's happening on your network and in your private cloud. It's also important to note this is kind of when you talk about different types of private cloud software. This is really what you think of. So this is really where like a Cloud.com or Eucalyptus or an Open Nebula. This is kind of they're the visible side of things. They're what you interact with, the user interface or the API. And we've got compute nodes. These are just kind of the big beefy machines that sit out there and are virtualized. The larger the better. More memory, more CPU, more storage, things like that. And in a typical case, you layer on top of this a hypervisor, which just slices up that machine into multiple pieces. So you take some big rack mount servers, you load on the hypervisor that's supported by your management node. And the management node is now able to control that and send commands to it and start launching virtual machines on it. In a typical example, you might have one of these in a small proof of concept to hundreds or thousands if you're trying to virtualize your entire data center. And then you need to have some kind of storage pool system. The actual technical details of these are always dependent on the actual management and cloud layer itself. So some typical technologies are iSCSI type exported file systems, NAS systems, storage area networks, NFS, things like that. But in the storage pool system, this is going to be taking the place of an Amazon S3 system. So this is where you'd store images. This is where you'd store maybe your S3 objects. This is where you would create EBS files or EBS volumes that you're attaching to virtual machines. And then you have to all link it all together. So most of these have some specific requirements as far as how you set up the lower level networking, as far as virtual LANs, what kind of routing is done, whether or not you're going to be communicating to the public internet or not. If you're going to keep this all private, that's one type of architecture. If you're going to open it up and allow other people, maybe from remote locations, to interact with it, that's a whole nother scenario. And then what we'll talk about a little bit later, the RightScale component of this. RightScale doesn't manage physical computer systems. We don't care about those things. That's not our detail. So we rely on some kind of management, some kind of low layer cloud enabling technology, and we just communicate to that through an API system. So we query that for what kind of resources are available out there, what we can do, and then we also issue API commands to the system to go ahead and launch your machines on your behalf. Oh, okay. So we've got a few different hybrid kind of cloud architectures that you may have heard of. What we've really discussed already is just the private cloud. So that's 100% of the virtual machines running in your private data center, in your private space under your own control. Another example is a hybrid cloud scenario where you're using some portion of your own internal data center that's been virtualized. So you're running a cloud.com in your local location. But you may also want to use selective resources in other locations, such as Amazon in different regions. So it just really means that it's some combination of public and private cloud space. And then we have what's called cloud bursting, which is, you want to capitalize on all the internal private cloud space that you have. Maybe you have 50 machines that are running inside your own private cloud. But a couple of times a year, you get a spike in traffic. Maybe it's for online ordering. It's coming to Christmas time. But you don't want to necessarily build out for that kind of high demand since it's only a couple of times a year. So what you do is you max out your internal capacity and you automatically burst out into the public space as needed. So it's a nice bucket, so you don't have to really worry about the details. Whenever or wherever this spike occurs, you're able to spill out and take care of that excess capacity. So why multi-cloud and these hybrid clouds? Some of the reasons here are just maybe you want to get a cloud closer to where your customers are, where your offices are. There's no sense paying these charges as far as data transfer or speed and performance issues as far as connecting these different locations together. It might be just a lot easier to go ahead and move that private cloud closer to that location that you're servicing. High availability, so you can have redundancy. You could have one cloud backing up another cloud. And also, just pick one. Oh, this is a good one too, is also freedom of choice, no lock-in. So you might be running different cloud architectures and different cloud enabling technologies in different locations. That's completely feasible to run a Eucalyptus cloud in one area, cloud.com in another area. Might not be practical, but it is definitely possible. The question is really, if I learn something now, will that be useless later on? Am I going to be wasting my time? How complicated is this stuff really? So the answer is really, there's going to be an entry-level learning curve on a lot of this stuff. So it's just some of the concepts like I've been talking about, and maybe some of the ways that RightScale communicates to your private cloud. And those fundamental architectures and communication channels won't change. So once you learn that, it's going to be great. Maybe some of the fine details will change, but it's not going to be a revolutionary type shift. So, okay, so we talked about some of these, so I won't go into all these in great detail, but why are customers coming and wanting to build out these private clouds, and what are some of the cool benefits of doing this? So one is obviously you get to pool all your servers together. You get to aggregate all your servers into this, kind of virtualized space, and you save money by having fewer servers running. But what you can also do is once you layer on this cloud architecture and technology on top of your physical servers, you're able to abstract that out and then create these kind of pools of resources that you can now assign and manipulate in interesting ways. So if I take 50 servers, I virtualize those, I can maybe be running 200 different virtual machines, 200 different operating systems on top of this. But that's not just 200. I can now start breaking that out into 50 here, 50 for research, 50 for development, 50 for test. And that's kind of cool, but that takes a lot of interaction. That takes a lot of administration time. What you can also do, which is an interesting feature of this, is what we consider a self-service type model, where you enable the end users, the actual consumers of these resources, to be able to go in there and define their own resource pools and their own applications and their own environments, and be able to serve themselves within minutes. So in a typical IT environment, maybe what they would be doing is, if I wanted to have 10 servers running and do some kind of research project on that, I have to go talk to IT, have them, requisition some servers, build them out, provision them, configure them, and whatnot. And that could be days or weeks. Whoa, that could be days or weeks. But through this kind of self-service model, you publish to them what kind of resources, what kind of servers that they can run, what kind of machines, what kind of applications even. Publish it to them in a portal type environment. They can just check a few boxes, say, hey, I need this kind of application stack on this kind of server, and they press go, and 5 minutes later, they're running exactly what they need. And when they're done, those resources get released back into the main pool for other people to consume. So you're really optimizing what's happening in your data center. There's not this wasted, inflexible kind of environment. So everything's very fluid and dynamic. Then also you have data considerations. When people want to privatize their clouds, there could be for compliance reasons. Maybe you have some very sensitive customer information that you want to keep internal. Maybe your management isn't really comfortable putting your intellectual property out in the private public cloud space. And also you might just want just more control over how this data is being moved around. One example of this is being able to, if you're working with large data sets, maybe in the medical research field, companies that are doing work on the human genome or something, instead of transferring all this data out to Amazon and back and publishing it out across the public internet, it's pretty much impractical. Not only for the price issues, for the data transfer, but also just for the speed. I mean, if you try and compute out what it takes to send like a petabyte of information to Amazon and back, it's going to take you weeks. So it's just not feasible. So if you want to get that advantage of the public cloud space, but you have this huge data set, why not bring the virtualization? Why not bring the cloud around your data? So you can take advantage of your fast connections, your own internal security models, all your own internal architecture. And then the last one is really you can build your own customized cloud. So when you think about it, Amazon as a public cloud, it's meant for the best of all worlds for all people, but it might not be the best for you. So by tuning and finding the right private cloud software, you really gain access to your own specialized hardware. Maybe you have faster inter-networking connections than Amazon would have. You're not virtualized or sharing this infrastructure with other people. So you really gain that benefit of taking advantage of all of your own internal architecture and customizing it to exactly your own needs. For some of the customers that I've talked to, what are some steps to success? How do you really proceed with this whole, I want to build a private cloud methodology? It's not a good idea just to go jump out there and just, figure it out as you go. Here's a few things that can maybe save you a little bit of trouble. So you got to really figure out what do you want this private cloud to do. Define what are your success, what are your criteria. What are you trying to accomplish with this private cloud? Is it going to be some kind of an architecture where you need to, you're heavily into computing cycles, or is it networking based? And then we have a question.
Yeah, what kind of applications from what you see are people putting on private clouds? And on the private clouds, are they putting more than one application on one cloud?
So when you say more than one application on one cloud, do you mean on like one server, one virtualized server, or just, okay. Yeah, so I think what I've seen a lot is that customers are looking for performance, and they might have a lot of servers, so they don't mind putting maybe a 1-to-1 ratio of virtualized, like an application, a database to one virtualized server. Whereas in a typical public environment, you might have, on some of the different instance sizes for Amazon, you might have one application being shared, or 4 or 5 different customers sharing the same server. So I think a lot of them do it, in a 1-to-1 ratio for that. And a lot of the examples that I've seen so far are either maybe database servers because they want extra performance that they're not getting out of the public cloud space, or if they've got a lot of servers, they might be doing actually a web application type servers. So I've seen like flash servers and kind of really weird stuff. It really varies, I think. One thing that's you can say about the private cloud space is that people are really experimenting. There's no real hard and fast rules yet. So we're starting to see different successes, but I don't think anything's been cemented yet.
Some people are putting email on some of the private clouds also.
Yeah. Yeah, that could be done too. I mean, traditionally Amazon had a problem, which they've kind of corrected as far as being able to send email out from the public cloud space. But I could see that as being a good use case, definitely. And then also some of the other successes, committing some resources. Realize that if you're going to be building this stuff up, you're taking the place of Amazon, so you better have some resources, some people that are either going to learn or have learned about private cloud space, that know about networking, and then also that you're going to be willing to dedicate those people to be kind of pulled off other projects, because they're going to have to focus on this. It is not as simple as maybe some people purport it to be. And it also does cost money as far as training and staff, and also for hardware. Unless you already happen to have a spare data center sitting around and sitting idle or something. And then there's also some other intangibles. It might force you to kind of rethink how you're doing your business operations. Instead of bending the cloud in this kind of environment to you, you might have to change some of the way that you're looking at things, where you're storing your data and whatnot, and how you're transferring and manipulating that information. And then also it's a good idea to always start small. If you think that you want to be the next Amazon by building this private cloud space and leasing it out to people, start small, work out the kinks, test what you really see as performance from what is kind of the hyped performance, because different applications vary. And then, let's talk a little bit about what RightScale does to improve upon this and actually manage this stuff. So One of the things that we do is this kind of cloud portability concept. So RightScale doesn't manage infrastructure. I mean, it doesn't really create the infrastructure. We don't, at the low level, handle that. So we don't really care what cloud enabling technology you're going to use. You can use cloud.com, you can use Eucalyptus, you can use whatever comes out on the horizon there. That's irrelevant to us. What we want to do is we want to enable you to be free to deploy your applications quickly and seamlessly in any one of those kind of location pools. So you're able to take your Tomcat application that you've been working on in Amazon, you've got it working, you say, great. Now you want to save some money and take advantage of your own infrastructure. You can take that same template after you've connected up, say your cloud.com private cloud to RightScale, and you can launch that exact same template. So you can run that exact same Tomcat server with no changes right into the private cloud space. And ideally, if it's written well enough, as we start adding other private clouds, you'll be able to take those same assets and launch them in any kind of combination between public and private clouds. That's really the goal for us. And then we also kind of we try and increase your control and your ability to do work with these things. Instead of managing single servers like you do in a traditional Amazon environment or in a public private cloud environment, we allow you to group these things into what are called deployments. So you can work with these groups of assets no matter what resource location they belong to. So I can manipulate and I can run scripts and I can change environment variables across 50 servers, even if each one of those or 10 of those are all in different clouds. So to me, they all kind of act as one homogeneous unit that I can work with. And then what we also try and do is, as we're learning, along with everybody else, we're trying to develop best practices that we're publishing out there for people. And so we're trying to do some of the legwork and get people exposed to this. And we're also really trying to push a community aspect around this so that other people can go ahead and contribute to these same assets. If any of you guys were here for the last breakout session, and Joseph talked a little bit about this, but what really enables this is the concept of server templates. And what is that? That's just kind of the instruction set that defines what a server is. So it contains information about what the operating system is. And then as the machine starts up, as I tell it to launch this server template in cloud.com, it pairs that up with an image that already exists in that cloud, which is just the base operating system, the very bare bones system. Once that server goes operational, it starts then running through these set of configuration instructions to go ahead and bring it and turn it into a database server, a web application server, or whatnot. But as far as the cloud itself is concerned, your private cloud, it's the exact same image. If I launch a database server in cloud.com or a web server, it all starts the same. It's the same base image. Yeah, the question? So I mean, the whole methodology behind this is that we abstract, so we provide or we enable you to create your own base images for any of these private clouds that you might have. But instead of wrapping into this base image that you ship out to all these private cloud areas, instead of packaging in there all your software and everything, so that you have to do patches and maintenance and updates, you take that all out and you turn them into scripts that are run after the fact. So those are executed at runtime, so you never really have to change that base image. Once it's got the connectivity and the low-level operating system on it, you're good to go. So then if all of a sudden I decide, oh my gosh, there's a security release that needs to be done, all I have to do is add it as a script. It will dynamically configure that the next time I launch and fix that problem for me. And then also on this as well, so we've got these public scripts. Everything's open source. Everything's available. So we don't really hide any of this from you. But we also apply version control and stuff. So you can roll back and you can compare how things were set up in one location to another. And then this kind of gives you just a visual of this. So it's like the DNA. So the same way the DNA is not a human being, but allows you to create a human being. Our server templates are the configuration instructions, a set of code that tells it, hey, if I'm launching in a public cloud and I want to be a web server, go ahead and take this base image and apply my instructions and turn them into a web server. So you're spawning these different kind of objects here. So it's very agnostic. You just create one server template, and ideally launch it to whatever it is and whatever we're supporting. We take care of the translation and all that kind of stuff for you. Yeah, so you can build your own custom images. We provide RPMs and Debian packages which install this right-link agent on any kind of image that you have. So if you want to see exactly what's going on or roll your own in a sense, that's not a problem. I can't really speak to, I don't know what would happen. Depending on what version, how if you used one of these things from 2 versions ago versus in the next.
I'm hoping that you guys are thinking through this.
Yes, we are.
Because this is quite a big challenge.
Yeah.
So, especially us. We do a migration upgrade path. It's not easy, and you've got to put a lot of attention to a lot of details.
Yeah. Well, let me tell you, maybe this will. So what we do is this agent is pretty much like a bootstrapping sequence. So it has the bare minimum code on there. So what we're moving towards is we bake this into the image, or this is what gets installed with the RPM. And then on first launch, it goes ahead and connects to RightScale and says, hey, do I need to update my code base? Are there patches? Are there updates? And so our goal is to keep that base level connectivity there and move everything up as as a software package. So it all happens dynamically. So if I'm sitting at my console and I say, hey, I want to launch a database server, what that does, that sends an API call out to the private cloud. The private cloud just starts up a very base like Ubuntu operating system, almost nothing on it except RightScale. RightScale then makes a communication call, or that virtual machine makes a communication call back to RightScale and says, hey, who am I? And it says, OK, you're going to become a database server. So then it starts passing down a set of scripts to that server. That server, those scripts say, hey, go to the repository, download the database, install it, make these configuration changes. So none of that stuff actually resides on the virtual machine until after it goes operational and has contacted RightScale. That's how you can be really dynamic. So what's happening here? So RightScale, when we do an initial cloud rollout, when you communicate, you go into our dashboard and you tell RightScale, I want to open up a channel. I want to provide some credentials which authenticate RightScale to send API calls to your private cloud. That's the first step. We have to be able to be authorized to talk to your private cloud. Yeah, and that goes over the internet. And this is what's happening. This is where it's labeled kind of legacy right here. Right now, we're just doing straight SSL, API calls to that endpoint of your private cloud. But when we talk to launch up a virtual machine, that's a different process because that's the agent is actually installed on the image itself, and that image just makes calls to RightScale. That's irrespective. So you could think of it this way: you have RightScale being authorized to talk to your cloud just overall. And then you also have the virtual machines themselves which start up, which also need to get communication from RightScale. And that's kind of a different aspect. So on the top line, we've got the legacy, which is kind of what I just described, where we've got this open SSL. It requires you to have ports open to your firewall, which a lot of administrators do not like, obviously. So what we're doing is we're developing what's what we call a gateway system, which is an on-premises behind the firewall system. So what we're going to do is basically take this gateway, deploy it on the other side of your firewall. That will handle a lot of your credential information. All the virtual machines, all the private clouds will talk to that. And then it will make pull requests from our system. So you don't have to keep your firewall open. So that's coming out very soon. So we are thinking about this. And what's going to be great about this is there's also API plugins or modules. So this gateway can be defined kind of in an open sense, so any cloud provider that comes on the scene can publish to our spec and be able to talk to our gateway and send information back and communicate to RightScale. So this kind of just, this is just more of this. I don't think we have too much more time. Do you guys have any more questions, or I can go ahead and, we've got about 5 minutes? OK, well, let me just pop into the RightScale dashboard really quick and just show you a few things, because I think it might be valuable.